2 of this session concerning risk, quality and environment. My name is Pernilla Bergstedt. I work for the Swedish Transport Agency. I have also attended the A&M committee and I will be your chairman for this session. I hope you had a pleasant lunchtime. Sorry. And I know it can be hard to stay awake after such a good food. But I also know that we have 5 very interesting presentations, so I don't think that would be any problem. The time is as short as it has been for the other sessions, so that means 15 minutes for each presentation and hopefully some minutes in the end of the session for questions. So let's start with the first gentleman, who is Mr. Omar Fritz Eriksson. He is head of the Innovation and Project Division at the Danish Maritime Safety Administration. Please, Mr. Omar.
Thank you. Good afternoon, ladies and gentlemen. Very happy to stand before you once again. I will talk about the risk assessment program called IRAP. Why would Ayala develop such a tool? We have seen this a couple of times before during this conference. SOLAS says that we should take account of the volume of traffic and the degree of risk. So we need some tools to assess risk. As you may know, Ayala has 2 main components of what we call the Ayala Risk Management Toolbox. There's the PASA, which we will hear more about in a moment. It's a qualitative model, and then we have IRAP, which is a quantitative model. On top of that, we of course have the ability to simulate, etc. as a part of the toolbox. The PASA, which we will hear more about, has been around for a while and it's very well working. But IRAP has been around for a while as well, but the first version of IRAP wasn't perfect. When we tried to evaluate it, we found some strange results and we discovered some faults in the coding basically, so we decided to try to mend it, but it was an impossible task, so we started from scratch. The first release of IRAP Mark II was in 2009, just about a year ago. And I will take you through some of the steps when using IRAP, some of the background information on how, behind the thinking of IRAP. A lot of people have contributed to IRAP. We have universities, scientific experts in this field. We have national members, and we have industrial members. Gatehouse is the company that has developed the code, basically, and not the least, the Ayala Secretariat, the Secretary General being very interested in this. So, risk, many of you may know this equation, is the product of probability that an undesired incident occurs and the consequences of this incident. Often you will see this put in a matrix, so that you have the likelihood and the impact on each axis. What we do in IRAP, or with IRAP, is to look at the probability part only. We do not look into the consequence domain. It is entirely possible, however, to add that on once you have the results of IRAP, but it is the probabilities that we're looking at. And probability probability of an incident is proportional to the frequency of incidents, you know, how many per year. So IRAP models causal relationships between a number of factors and the unwanted incidents such as groundings and collisions. It is a purely probabilistic approach. The first version of IRAP mixed a probabilistic approach, this part, with some design rules, the Piank manual, if you will. And we've gone away from that. We just want to look at the probabilistic approach for the time being. So how do we do it? What we do first is to calculate or estimate a number of candidates, what we call a geometrical frequency for an incident. We multiply that then with what we call causation probability, ending up with collision frequency. So we have a number of possible incidents, collisions in this case. We multiply it by a factor, and end up with the collision frequency in case of collision. So, as an example here, you have traffic going this way. The traffic is distributed like this.